Hello and welcome to what is a new chapter in my journey here on YouTube. This is the AllPowers S300 battery storage box, and I was contacted by AllPowers to do a review on it. So I guess I've made it to the big leagues of YouTubers doing product reviews. Yay! Please feed the YouTube algorithm by giving the video a like. If you want to see more like this, click subscribe and ring the bell to be notified of new videos. If you want to chip in on my expenses, I now have Patreon and YouTube memberships. Of course, for the sake of transparency, here are the terms of our agreement. Everything I say is my personal, true opinion, and AllPowers has no editorial control whatsoever. I will keep this unit after the review, but I haven't been compensated in any other way. I'm now registered in their affiliate program, so if you do decide this is something you're interested in, go ahead and use the link below in the doodly-doo. You'll pay the same price, but I'll get a small commission. Okay, so let's move forward with the review, and then because I'm that kind of guy, we're going to take it apart and check out the battery cells and the battery management system. So let's start with the basics. This is an AllPowers S300 portable power station, model AP-SS-005 S300 V2.0. It's the smallest unit in their line in this form factor, which goes all the way up to 12 times the power and storage with the R4000. AllPowers was founded in 2010 in California and sells a wide range of battery storage systems and solar panels. They currently have 3 R&D sites in China and sell their products around the world. I checked several review sites and found that when the unit works, people really like it, but there are a number of users that have reported a problem with functionality or a warranty return problem. As with all self-reported reviews, take this with a grain of salt. First of all, we should check the price to make sure it's reasonable. In the US, AllPowers sells it on their own website for $129, which seems like a complete bargain for the functionality that you get. For some reason, the company also has their own store on Amazon.com, where they're selling it for $169. I can only suspect why they're discounting it on their home site, perhaps in advance of a newer model. In Europe, it sells for 199 euros, but that's going to include the punishing amount of tax and duty that EU countries apply. Even with that, it's a great price. With a 2-year warranty, that'll get you through the initial unboxing, early life failures, and a good amount of use. Now let's look at the detailed specifications. It has 288 watt-hours of energy storage. That means in a perfect world, you could power something at 288 watts for 1 hour, or a 144 watt device for 2 hours, or a 29 watt device for 10 hours. Voltage times current equals power, and power times time must always equal 288. You can always calculate the amount of time you'll get pulling a certain voltage at a certain current, but due to efficiency losses, you'll always get slightly less. Conveniently, it can charge and discharge at the same time, so a solar panel will give the battery more life to power your target device. So we know it's essentially a big battery with a bunch of inputs and outputs, but how can we put it to work? Simply put, you can use it any place you don't have easy access to AC or DC power. Reminds me of an ad I saw for a tactical flashlight where they listed a dozen places where it would work, but it all boiled down to use it when it's dark. Since it's compact, light, and easy to carry, you could use it for jump-starting the dead 12-volt battery in your vehicle through the car's 12-volt plug. Alert viewers know this is critical for me because if I forget to flip a switch in my electric 914, it will drain the 12-volt battery. And I can't use the big battery to jump the little battery. Now there's no power outlet near my parking space, so this unit would be perfect to charge the little battery back up and then be able to drive the car. Another great use is during a power failure in your home. Use the built-in lights at night, keep your phone charged, and power your internet Wi-Fi router. Other uses could be remote work sites, emergency preparedness, camping, boating, picnics, festivals at the beach, extending the life of your phone and laptop, running a fan, or running a small cooler to keep food fresh. So, I'm sold on the features and the flexibility, but who are the competitors? Doing some searching, I found that Bluetti, Jackery, EcoFlow, and Anchor make similarly sized and priced units at this low end of the scale. So when you're looking to buy, check the reviews on the specific model you're interested in, and also look for sales, as they occasionally pop up. Now, let's move to the unboxing. The packaging is done well, with shaped foam pieces snuggling the unit in the box. It comes with an AC power brick and cable, with a 2.5mm DC plug that goes right into the side of the unit. My region's product manual is pretty comprehensive, and it has sections in English, Chinese Mandarin, German, and Japanese. It comes with a small zipper bag for accessories and masses at exactly 3 kilograms. For fun, go and Google mass versus weight. It has a low center of mass, so there's little chance of tipping it over, and the quality construction in the parts looks good. The power in and out specifications are printed on the bottom of the unit, so remember to look there when plugging something in. Now, here's the extensive list of powers in and out. On the front panel, there are 2 Euro-style AC sockets with water-resistant covers, and you'll get the proper sockets for your geographical region when you order. These supply a combined 300 watts of continuous AC output with a temporary surge to 500, and that's going to cover the vast majority of devices needing power, except something that sucks a ton of power like a hairdryer. There are 2 very bright white LEDs on the left and the right side, which are supposed to enter emergency flashing mode if you hold the button for 3 seconds, but I couldn't get it to do that. A short click of the power/Bluetooth button lights up the display, while a 3-second press turns on Bluetooth so you can comprehensively control it with an app on your phone. A QR code in the manual lets you download from the Google Play Store or the Apple App Store. Next is the DC power button, which only needs a short click to enable all DC in and out jacks. To the right is the AC button, which requires a 3-second hold to enable AC output, which is strangely inconsistent. At this point, the internal fan spins up to keep the inverter cool, but with quite a low level of fan noise. A graphical display in the center shows the system status, including Bluetooth, USB, DC, and AC, the amount of time left at the current discharge rate in hours and minutes, the state of charge, and the power going in and out, so you have a really good idea of what's going on and what you can expect over time. On the left side is a 12-volt barrel plug for the AC adapter, or your own custom plug, because there's no spare cable provided. Next is a solar or another DC input using a small Anderson power pole connector, which is common with high amperage DC connections like solar, computerized telescopes, amateur radio, robotics, and radio control cars. Again, an Anderson connector or cable is not included, but there are many solar module MC4 to power pole adapters available online. The maximum input is 20 volts, so be sure to get a matching solar panel. AllPowers has their SP012, SP020, and SP026 foldable 160-watt solar panels, which come with a barrel connector to match with this unit, and they claim 4 to 5 hours to charge, which seems reasonable. There is a 12-volt car plug with an input of 12 to 20 volts at 5 amps and an output of 12 volts at 5 amps. The maximum DC input is a combined 140 watts, which is very good. On the right side, there's a row of USB connectors, starting with one USB-C with PD or power delivery functionality, which is good for newer phones and laptops and can handle 60 watts in and 100 watts out. Then 3 USB-A jacks, good for 3 amps each, while maxing out all 3 ports at a combined 7.2 amps. Then 2 more barrel jacks for DC output, again with no provided cable. On top there's a wireless phone charger using the QI standard of 5 volts at 1 amp. Typical QI efficiency is only 70 to 80%, so using a cable is always going to be faster. Unfortunately, I couldn't make the wireless phone charger work. When I take it apart, I'll see if there's a loose wire inside. Importantly, the lifetime charging cycle count is listed at over 800, which you're not likely to reach in your own lifetime. The temperature ranges 0 to 40 Celsius or 32 to 104 Fahrenheit because lithium cells don't like to be too hot or too cold, and especially never attempt to charge the unit below freezing. And finally, a super handy carrying handle. Since it's only 3 kilos, this makes it a breeze to carry to wherever power is needed. And let's go ahead and try and power it up. I'll push the power button, and nothing's happening. That's a little disappointing that the unit doesn't work out of the box without getting a fresh charge to bring it up to speed. So let me take the time to go ahead and do that. Okay, after all that preamble, let's move to the exciting world of testing the thing. And as you can see, the battery is at 0% after I plugged it in, but it's putting watts in, 40 watts so far. The time to do a full charge using the included AC adapter was 4 hours and 27 minutes, and the 60-watt adapter topped out at 52 watts on the screen. Doing nothing, the unit says it has 110 hours available, and turning on one of the front LED lights drops the available time to 59 hours, and with both on, it's 40 hours, and that's a lot of bright light for a long time. I don't have a solar panel with the required maximum of 20 volts, so I simulated it with my benchtop power supply. Setting for max power, it took 2 hours and 53 minutes for a full charge, which is good to charge up a low battery or let the unit keep up with the power draw while discharging into a target device. Let's try powering some AC devices and see how the unit reacts. Here's an easy one, an LED light bulb rated at 4 watts. It worked, and the unit showed 0 watts being consumed, so I think I just invented infinite power? No, it's just that the display's current sensor isn't super accurate, which is fine. Fans are a good test because they pull a lot of power and the motors are sensitive to the quality of the AC sine wave. My fan pulled around 40 watts on low and 46 on high. The motor was very quiet and therefore happy with the AC sine wave. It wasn't buzzing as you would hear with a bad PWM inverter. I plugged in my laptop's AC adapter and it handled the load while running a video render and charging the 30% internal battery, hovering around 57 watts, which is close to the adapter's 65 watt rating, projecting 3 hours and 14 minutes of supply. Now let's try some high power devices. First is my soldering pencil, pulling around 100 watts to heat up, then dropping down while maintaining the temperature. My hot air SMD soldering station was too much for the unit, which shut down the AC output when I asked it for too much power. But this is a good sign for the unit, both from the overpower protection and the quick automatic reset. The last AC test is my 3D printer. The unit handles the printer's boot up sequence well, but I got an automatic AC shutdown when the printer asked for too much power when starting to execute the print. Moving over to the DC output, I plugged my laptop in directly with a USB-C cable, and the unit handled the 63 watt power draw well while running a video render and charging the 30% internal battery, projecting to run it for almost 3 hours. The last test will be a cute little USB-C based SMD reflow soldering plate I recently picked up. I plugged it in directly, and it easily handled the 50-watt draw while heating up. The top of the unit clearly indicates a wireless phone charging capability, but I couldn't get it to work. I noticed on some of the company's product pages that wireless phone charging is only included on certain models, but there's no indication whether this one has the internal circuitry, which is odd. There's a barcode in the manual to download their iPhone or Android app called AllPowers. It only has a 2.6 rating in the Google Play Store, with many complaints about intermittent connections and a lack of user security. The app basically mirrors all the information and controls on the front panel, which could be useful if you're within Bluetooth range but not close enough or inconvenient to press the buttons. On launch, it allows you to connect a battery station via Bluetooth or Wi-Fi. It quickly found my device and connected to it. It shows the state of charge, remaining time, input and output power, and has the ability to toggle AC and DC power and turn the front lights on and off, and everything seemed to work well for me. Now that we've seen what it can power, let's check the quality of that power. Using my cheap RS Pro USB-based oscilloscope, let's check the alternating current waveform. Now here's a picture of a perfect sine wave. Theoretically, this is what all AC output devices should provide. And this is the waveform I get when I check the power coming right out of the wall from the electric company. Not perfect, but it does the job. And this is the output from the AllPowers unit. Even more slightly non-sinusoidal than the wall power, but again, it does the job, and the fan motor didn't complain about the shape of the waveform. Now, this is what you can expect with a low-quality PWM inverter, and we're nowhere near that. So AllPowers' claim of a nice sine wave inverter holds up. As the last step in our testing, let's take it apart. Of course, AllPowers won't condone disassembling the unit, so don't try this at home. As Adam on Mythbusters says, we're what you call experts. First, I'll remove this little cover on the front, and then do the usual pop off the rubber feet and remove the screws. Peeking into the new hole in the front, all I can see is a circuit board with what look like the battery balancing resistors for the battery management system. I wonder if this hole is used for another purpose on other models. With the rubber feet peeled out, I see that the screws have a security Torx feature. You can barely see it with the bad focus on my camera, but my Torx tip had just enough bite to unscrew it. And here it is in all of its glory. I'm going to have to take a look here, but not go any deeper into the unit for safety reasons. I'm not going to go all Big Clive here. I removed the plug that takes AC power from the board up to the two receptacles. Most of what you see are the components of the AC power supply. And I see that the connectors have been dabbed with goop that will help hold them in place. The fans have also been gooped to avoid any buzzing. The connectors on the back of the AC receptacles are also covered in goop to avoid electrical shorts. There are two data connectors along the right edge. The first is a serial port, and the second is an SWD serial wire debug port, which is used to load software and to do debugging with ARM-based microprocessors. So it's likely there's one of the popular ST microchips in there somewhere. Interesting that it's a removable connector, as most boards save money and just use flat pads on the board, and the software is loaded in the factory with pogo pins. Along the back of the aluminum heatsink, we can see 8 MOSFET transistors, which create the sine wave of the AC power that we saw in the scope. The more MOSFETs, the better the sine wave. And that's a good size heatsink and fan combination to keep the MOSFETs cool. Next, I spotted a connector and wire going to the wireless charging pad. So there's something in there, but it's not working in my unit. I wonder if it's enabled in the software or not, depending on the model. Lastly, I noticed that they're using brass inserts and bolts to hold the case together, rather than screws into a plastic hole. This is yet another example of the good build quality of the unit. Let's wrap this up with a discussion of the battery pack strategy. AllPowers describes the cells as ternary, which means they use the NMC chemistry, or nickel, manganese, cobalt. NMC cells have a higher capacity and are lighter than other lithium cells, so they're a good choice for this unit. First, we can see that the battery pack is reading 16.19 volts, which gives us our first hint. I've put 4 of my 18650 lithium cells along the side, and also checked that 8 will fit from side to side. This leads us to reason that there are 4 cells in series and then 8 groups of those 4 cells in parallel, for a total of 32 cells. This is called 4S8P. Now, voltage adds up in series, so to reach 16.19 volts at the unit's full charge, each cell is at 4.05 volts, which is a very happy place for an NMC 18650 cell to be. It's comfortably below its limit of 4.2 volts, and this helps to extend the life of the cells. Pack capacity adds up in parallel, with the 8 groups delivering the rated energy capacity of the pack of 288 watt-hours. That maths out at 2,432 milliamp hours per cell, which is on the low end of commodity lithium cells these days. So they're buying the cheaper and more reliable cells and passing the savings on to us. While AllPowers has made some compromises on this small size unit, I like it a lot. It's a very good price simply for the battery capacity and all of the in and out plugs. Pretty much anybody could make use of this, although it may spend a lot of time in the back of a closet until it's needed. But when it's needed, it will give you good service. Here's my list of pros and cons. Pros: it has the smallest capacity in its form factor of the line, but it provides solid portable energy when you need it. It has an excellent price. It has great flexibility in its in and out ports, and it's very well constructed. Cons: it was dead out of the box with not even enough charge to turn it on. Wireless charging didn't work for me, and there are no included cables for each connector type, and there is strong competition from other companies. Overall, I'm happy with it, and in my unbiased review, it's a solid unit at a great price. Before we wrap up, I'd like to thank my Patreons and YouTube members, Peter Bouvier, Puppy, and Craig, for their ongoing support. I see that a whopping 96% of my viewers are not subscribers, so please go ahead and click that subscribe button because it really helps out the YouTube algorithm. Thanks and take care, and I'll see you in the next video.